Hi everyone, welcome to the AMC 8 live problem solving session. We have with us here Hari, Agastya and Anusha would be helping us with the problem solving session. We thank them for their time, and we also have Dr. Gauri, Dr. Krishna Gauri and Mrs. Kalasarojini to help us volunteers. My name is Vinay. I'm a volunteer for the workshops team. Okay, and also our Math B regionals will be on April 9th or April 30th, depending on the chapter that you would be participating from. So yeah, please take a look at the contest schedule in your local chapter and register. Okay, so let me introduce Hari and then he will introduce the rest of the panel. Hari Surnedi is a high school senior with a passion for helping and teaching. He is involved in a lot of things, including EMT, volunteering at the hospital, North-South, tennis, Science Olympiad, 3 honors society, and two of his own clubs, and much more. He is a coach for North-South and a student lead for the Math Magic team, where he has set up and taught live solving sessions, helped with the question bank, and coached the Wise and Well program. And going forward, he would like to be an orthopedic surgeon. Welcome, Hari, and over to you.
Hi guys, it's great to have you here, and yeah, pretty much I'll first explain what AMC is, and then we'll talk about who we have here, and then start solving those problems. So AMC 8 is a middle school math competition. It's for anyone, again, we say middle school, but 6th graders and sometimes even 5th graders can do this competition. That being said, it is middle school level, and there are 25 questions that you will have 40 minutes to answer for. If you guys have any more general questions, you can always put it in the chat, and me and whoever is free will be answering those questions. With that said, we have two great panelists today. One is Agastya and the other is Anusha. So some things about Agastya. Agastya is a high school sophomore that is attending Edison High School STEM Academy. He's in many STEM clubs, quiz bowl, math team, and Science Olympiad. He has a lot of passion for logic-based solving questions and computer science and coding. In his free time, he likes watching movies and going on vacations. He also enjoys teaching math, and he'll be doing the first 8 problems. We also have with us today Anusha Iyer, which you guys may have noticed from other solving sessions. She's also a high school sophomore at the Academy for Information Technology. She has been in many honors classes from a young age and is very advanced in math. She loves helping people with math problems and simplifying complex components to math. And she's in a multitude of clubs and in many honor societies. So I guess with that, we can start our math, which you're all dying for. This session is 1 hour, 30 minutes. And Agastya, you can take it away.
Hey everyone, so let's get started with question 1. The math team designed a logo shaped like a multiplication symbol, shown below on a grid of 1-inch squares. What is the area of the logo in square inches? So how we approach this problem is that you know that every square is 1 inch. So in that case, because it's 1 inch, you would have a 1 inch side length for every square. Now the area of a square is basically the side length squared, which means it's 1 times 1 is equal to 1 unit squared. That's the area of a single squared. Now we apply that to the logo. So first we count the amount of whole squares that are in the logo of the math team. So over here we can simply count 4 whole squares. So what we do, we just multiply 1 unit squared times 4 to arrive at 4 units squared. But then how are we going to deal with the rest of these triangles over here? So as you can notice, the triangle is exactly half of the area of a single square, because the diagonal, it passes straight through the middle, this diagonal, making it half the area of a single square. So each triangle has an area of 1/2 unit squared. So after that, you would count the amount of triangles present. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when you have 1/2 unit squared for each triangle, then you multiply that by 12, you arrive at 6 units squared for the triangles. Now, in order to find the area of the entire logo, you simply had to add 4 units squared from the whole squared in the middle, plus 6 units squared from all the triangles on the outside, to arrive at 10, which is answer choice A. Is that clear to everyone?
Let's give them about like 5 seconds.
Mhm.
It's just, we're going to go through the first couple problems a little bit quicker because they tend to be a little bit more simple. But it looks like everyone's got it, so let's keep going.
Right. So now, problem 2. Consider these two operations. A diamond B is equal to A squared minus B squared, and A star B is equal to A minus B whole squared. What is the value of phi diamond 3 star 6? So first, using PEMDAS, what we do is that we look at the expression in the parentheses first. So we had to look at 5 diamond 3. I'm going to use a D as a substitute for diamond here. Then what we do, we simply treat 5 as A and 3 as B. Now you can notice we plug this into the diamond equation. So we do phi squared minus 3 squared. And that we get at 25 minus 9, which is 16. So the value of the first part of the expression, phi diamond 3 in parentheses, is equal to 16. So now we do 16 star 6. I'm going to use an S for simplicity here instead of star. So we can apply the same concept. We treat 16 as A and 6 as B. So over here, what you do, you plug this into the star equation, which is A minus B whole squared. So you can substitute the values, 16 minus 6 whole squared. So then we get 10 squared, which is 100. Meaning you arrive at answer choice D. We'll wait for a few seconds for everyone to digest that.
Yeah. Okay, it looks like everyone's got it, so
Let's
I
move on.
think we can go on.
All right, problem number 3. When 3 positive integers, A, B, and C are multiplied together, their product is 100. Suppose A is less than B, which is less than C. In how many ways can the numbers be chosen? All right, so what do we know here? We know that the product of the 3 numbers is equal to 100. And as they're all represented by different variables, and and A is less than B and B is less than C, we know that they're all different integers. And furthermore, what we know is that because A is less than B and B is less than C, A is also less than C. So that's what we know about this problem so far. So now we set up an expression. A times B times C is equal to 100. Then we go through some simple factorizations of 100. So one thing that we can start off with that satisfies all the conditions, being A being less than B, which is being less than C. So we just list them out here. So we do 1 times 2 times 50 equal to 100. And keep in mind that each of these numbers, this represents A, this represents B, and this represents C, and we'll go on for the next few that I show you. Another one that we can do is 1 times 4 times 25 is equal to 100. we can also do 1 times 5 times 20 is equal to 100. Now keep in mind, I did not use 1 times 1 times 100 in this situation, because because A and B would be the same in that case. And as A has to be less than B, that does not satisfy the conditions of the expression. So we can move on to A being 2, because there are no more situations where A is 1 and all the numbers are different, satisfying all the conditions. So we can move on to A is equal to 2. So what we can do 2 times 5 times 10, which is equal to 100. So in this case, you reach all the possible answer choices, and you have 4 different combinations that result in A times B times C equaling to 100. So now you know your answer is E, 4. Did everyone understand that?
So far, most of us have understood it. There is one question. I think one person's typing it out. So, one person has asked, is there a way to solve this symmetrically instead of trial and error?
By symmetrically, what exactly do you mean in that case?
I guess they're trying to talk about like using prime factorization to solve it.
Well, in that case, this is actually the simplest way to solve it, because looking at the choices, you know that there are only 4 max, right? So this would possibly be the simplest way, because you know that A would equal, there would be choices where A equals 1 and then A equals 2, but at this point you already reached 4 choices, so this would be the max.
Yes.
So this is probably the simplest way to do it. So in this case, with a low amount of problems, trial and error would be the simplest, but this is not exactly trial and error at the same time. You're just using common factors of 100.
Yeah. One person has asked to show them the prime factor way. If you'd like me, I can show it. Otherwise, you got it.
Oh yeah, if you can show it, then that would be great.
Okay, cool. Could you Control Z your stuff so then
Yeah.
to erase it in this problem. So guys, pretty much we know that A times B times C is going to equal 100. Well, if you guys have learned prime factorization in school, right? Prime numbers are pretty much unbreakable numbers, you can think of it, right? Like Lego bricks. There's a lot of ways to make 100. So I guess if we break it down, we have 2 times 50. We can break down the 50 into 2 times 25. And then we can break down the 25 into 5 and 5. So from here, we're really just looking at the number of combinations we can make, right? So again, you, as Agastya said, for A, you want to make A the smallest thing first and then slowly get to more, right? So right, you're going to make A 1, and then what's the smallest thing you can make B next? The smallest thing is you can make B is 2, right? So once you make A 2, you have to make C these numbers. So what's 25 times 2? That's 50, right? So then when you do that again, you're going to make A1 again. This time, instead of just using 2, you want to look for the next smallest thing. Well, if you multiply 2 times 2, you get 4. If you multiply 2 times 5, you get 10. Which one's smaller? 4 is smaller, right? So you get 2 and 2. And then again, it's just the same exact thing. There's going to be one more case for the 1, right? You're going to get 4. Instead of doing 4, you're going to have 5, right? If you have 5 alone, then you have to combine this 5 with these 2's. You're going to have 20. That's the max you can get with A being 1. If next you can do A equaling 2, then you get your final case of 2, 5, and 10. And Agastya makes a really good point. This is a multiple choice test, right? So it's smart to use your answer choices. Once you've hit a max of 4, you have proven to yourself that the answer is E. So wasting time trying to think of a fifth option is not that great, especially when you only have 40 minutes. I hope that you guys understood that, and good job, Agastya. So let's move on to the next problem.
All right, so this problem uses the concept of reflections. So in case you recall, we can treat M as a shape. So let me read the question. Problem 4. The letter M in the figure below is first reflected over the line Q and then reflected over the line P. What is the resulting image? So in this case, I would prefer to make the plane a bit bigger, actually.
So the question is not showing up yet.
Yeah, that's what I was.
All right.
Now we can see.
Yeah. So here, so we know that P is actually equal to the x-axis in this case, and Q is equal to this line over here, this diagonal line that passes through the plane. Let me put Q in a better area. All right, so let's draw our M. In this case, we can treat M as if we're as a shape. So whenever you reflect a shape over your line, you take the perpendicular, you perpendicularly like intersect the line, and then you draw the point of the shape on the other side of the line. So to illustrate that for you, for example, when you're looking at this point of M, and then you draw a perpendicular line across Q, well, this is not exact, but this gives you a general idea. The new point would be over here of M. So when you apply that concept for the other few points, you'd eventually arrive at a shape of M that looks like this. So to prove the perpendicular thing, you have that point related to here, this point related to the center, and this point related to here. So whenever you draw the line, it's perpendicular to Q. This creates a right angle over here. So it's a negative reciprocal of the slope of Q. Right, so then you reach your initial position. After one reflection, M, it looks like this. It looks like it's tilted sideways and then flipped over the line. So now you got to flip it over P. You apply the same concept, perpendicular reflection. But M is a symmetric object, so it doesn't really make any change in how M looks. So all you need to do is just plot it below the p-axis or the x-axis. So it'll look like this. And as you can see, the same concept holds. This point relates to this. The center point relates to the center point, and so on. So as you can see, by drawing a perpendicular line to Q and attaching a point to it, you can easily solve this problem just by drawing the shape and the points. So over here, this is our final position of M, which correlates to answer choice E. Did everyone understand that?
Let's give them a little bit of time to ask questions.
The key here is really treating M like a shape with points. So yeah.
So far, there's no questions. For the sake of time, let's keep going.
In this case, I'll keep going. Okay, problem 5. Anna and Bella are celebrating their birthdays together. 5 years ago, when Bella turned 6 years old, she received a newborn kitten as a birthday present. Today, the sum of the ages of the two children and the kitten is 30 years. How many years older than Bella is Anna? All right, so what do we know here? 5 years ago, Bella was 6 years old. So now we know that by 6 plus 5, Bella is currently 11 years old. And again, at the same time, 5 years ago, she received a newborn kitten as a birthday present. So as the kitten was technically 0 years of age when it was received, now the kitten will be 5 years old. So, and then they say, today the sum of the ages of the 2 children and the kitten is 30 years. So we can just set up a simple equation like here. So we know child 1, who is Bella, and the kitten, plus child 2, who is Anna, is equal to 30 years. All we need to do here is substitute 11 for B, Bella, and 5 for K, the kitten. So we substitute 11 for B plus 5 A equals 30. Then we get to 16 plus A is equal to 30. So we're really solving for an unknown here, and the unknown here is Anna's age. So then you subtract 16 from both sides to arrive at A is equal to 14. This means Anna is currently 14 years of age. And as the question asks, how many years older is Bella than Bella is Anna? So Anna is 14, Bella is 11, meaning Anna is 3 years older than Bella, which is answer choice C.
Good job. Let's give them a couple of moments. I think we're good. We haven't gotten any questions, so.
In that case, then we'll move on. One sec. Wait, just need a minute. All right, so let's move on to problem number 6. Problem 6. 3 positive integers are equally spaced on a number line. The middle number is 15, and the largest number is 4 times the smallest number. What is the smallest of these 3 numbers? All right, so it'll make most sense if we visualize this problem. So let's draw a number line. So as it says the middle number is 15, we know the midpoint is 15. And we can place the smallest number on one side of it and the largest number on the other side of it. So let's call the smallest number x, as we don't know what it is. And the largest number is 4 times the smallest number. So we just multiply x by 4 to get 4x as our largest number. In this case, we know that 15 is the midpoint of these 2 points, of x and 4x. So these 2 are equidistant. So in that case, what we can do, we can set up an equation. This is a relation. 4x minus the midpoint, which is representative of this half over here, is equal to the midpoint minus x, which is representative of this half over here. So think of it as distance. If this relation doesn't make sense to you, let's say that this is 4x miles, and this is 15 miles, and this is x miles. 4x minus 15 would give you the distance in miles of this area, and 15 minus x will give you the distance of this area. So hopefully that made sense to you. Now we proceed with the equation. So we add x to both sides. And we get 5x minus 15 is equal to 15. Oops, my bad. And then we add 15 to both sides. And then we get 5x is equal to 30. So we divide 5 from both sides, and then we arrive at x is equal to 6. So now we know that x is equal to 6. And look, the smallest integer of the number line is also x. So in this case, we can just simply plug in 6 for x, and we arrive at the smallest integer being 6. And there's no point of wasting your time solving for the largest integer, since the problem is just asking for the smallest of the 3 numbers. So now you know that your answer is 6, or answer choice C.
Nice. Let's again give them a couple more seconds. There's no questions pertaining to this question, so let's continue.
All right, let's move on. So problem number 7. When the World Wide Web first became popular in the 1990s, download speeds reached a maximum of about 56 kilobits per second. Approximately how many minutes would the download of a 4.2 megabyte song have taken at that speed? Note that there are 8,000 kilobits in a megabyte. So what you do, you use a technique here. So first, you start out with 4.2 megabytes. That's the size of the song you need to download. In that case, use dimensional analysis. So over here, this note is very important. It says that there are 8,000 kilobits in a megabyte. So you put 8,000 here. And watch the units very carefully because they're going to cancel out. You put kilobytes in the numerator, and then in the denominator, you put 1 megabyte. Right. So visualize this right here. So you have 4.2 megabyte times 8,000 kilobyte over 1 megabyte. We can treat these units like variables over here. And what we can do, we can cancel them out because as it appears in both the numerator and the denominator, they cancel out to equal 1. So we're just left with 4.2 times 8,000 kilobytes over 1. That was just to help you understand the process. So now, it says that there are 56 kilobits per second, which is the maximum download speed. So, and we know that it's happening at the maximum download speed due to these words right here, at that speed. So we know that the rate is 56 kilobits per second. So we can use the same technique and make sure the units cancel. So if you see a unit in the numerator at one point, we'll need to know that it'll appear in the denominator at some point or other in order for the units to cancel and to be and to have your desired units in the end. Over here, you want time, so you want minutes. We'll get there eventually, but you want kilobytes to cancel out at one point. So what you do over here, you put 1 second over 56 kilobytes. So this shows the relationship of 56 kilobytes of a download speed per every second. Now what you can do, you can cancel out the units again using the same technique that I showed you last time. The kilobytes will cancel out, and now you're left with seconds, and these already cancel out. So now you're left with the unit of seconds. Then you can multiply it again. So the answer is supposed to be in minutes. So we know that there's 60 seconds in a minute. So what we can do, we put 1 minute over 60 seconds. And using that same technique again, this cancels out. So what you're left with is, in the numerator, you're left with 4.2 times 8,000 over 56 times 60. So as you're not allowed to use a calculator on the test, you would have to do the multiplication in your head. But or on paper. But this is actually really easy. It's not as daunting as it looks like. Over here with the 8,000, since it's a 1,000 place and it's a 10 to the power of 8 times 10 to the power of 3, what you can do 4 times 8, 4.2 times 8, which is 33.6. Using simple multiplication, you can get that. And then after that, what you just multiply that by 1,000 because you divided 1,000 by 8 to get 8 over here. So you get your numerator as 33,600 minutes. Never forget units. And then the denominator, you apply the same strategy for 56 times 60. All you need to do is really 56 times 6 times 10. And over here, you end up getting 336. And then multiply the 10, you'll get 3360 in the denominator. Now notice here, instead of being daunted by this by these large numbers and having to do a large division problem, you can see that the number of zeros is 1 less over here than over here. So what we know is that the numerator is 10 times greater than the denominator. So that just simplifies to 10 minutes. And if you look at your answer choices, that is seen in answer choice B, 10 minutes.
There is one question. They just had a question about the conversion, and they're asking why there was a 1, I think, megabyte underneath the 8,000 kilobytes. So if you could explain that, it'd be cool.
So over here, it says 8,000 kilobytes in a megabyte, right? So you would put megabyte in the denominator here. It doesn't really matter where you put it, but you just need to show that it's units. Units is what matters. So over here, this technically is equal to 1. If you convert the megabyte into kilobytes, right? So we know that 1 MB is equal to 8,000 KB. Because this is a unit conversion. So therefore, you would put 8,000 kilobytes in the numerator and show its relation to 1 megabyte. So I hope you understand that. Yeah.
I think with that, we can continue.
Can I have the other 2 poll questions before we?
One more question, and then we switch.
Okay.
Yeah. Great. Cool.
All right. Check. All right. So what is the value of 1 over 3 times 2 over 4 times 3 over 5, so on, that means everything included, times 18 over 20 times 19 over 21 times 20 over 22. So there are a lot of fractions in this problem. So one thing you know is that since it's a lot of fractions, it'll be extremely tedious and time consuming to go by and multiply every single one of them, the numerator and denominator. It'll take forever. So there's actually a simpler strategy. So arrange the numerator. And also this so on over here, it just means that complete the pattern, fill in the values. You establish the pattern of the numerator increasing by 1 by each step and the denominator also increasing by 1 by each step. So let me show you some values here. 1 times 2 times 3 times 4 times 5 times 6, so on, times 18 times 19 times 20 over 3 times 4 times 5 times 6, so on, times 18, 19. All right, so over here, a principle that you can apply if you have the same term in the numerator or the denominator, they will cancel out to equal 1. So let's take, for example, the 3. We see a 3 in the numerator over here. We also see a 3 in the denominator over here. So we can arrange them differently. So what these do, they just simply cancel out, because 3 over 3 is equal to 1. So now we're left with 1 times 2 times 1 times 4 times 5 times 6, so on. And 1 times 4 times 5 times 6, so on. And by the identity property of multiplication, multiplying an entire expression by 1 is literally that expression itself. So the 3's simply cancel out. And now what's great is that we can apply this concept to every single number. So the 4's cancel out. Except we can't apply it to 1 and 2 because there's no 1 and 2 in the denominator. So 1 and 2 remain as they are. The 5's cancel out, the 6 cancel out. And everything cancels out in this ellipse because they represent the values from 7 to 18. So 7 to 18 is present in both the numerator and the denominator. So everything here cancels out. 18's cancel out, the 19's cancel out, the 20's cancel out. So now what we're left with is a whole bunch of 1s, and 1 times 2 in the numerator times a lot of 1s over 21 times 22 in the denominator. And again, as said, by the identity property of multiplication, it doesn't matter how many 1s you're multiplying something by, the value of that still stays the same. So the numerator is 1 times 2, and the denominator is 21 times 22. So we can rearrange this as 2 over 21 times 22. Now, instead of having to multiply this entire thing, we can use the same property and then simplify 2 over 22. So we divide both the numerator and the denominator by 2, which is the least common denominator of both expressions, of both numbers in the numerator and the denominator. So what we're left with is 1 over 21 times 22 over 2, which is 11. So then in that case, we get 1 over 21 times 11. Doing the multiplication is actually really easy for this, because what you had to do is just do 21 times 10, which is 210, and then just add 21 to that, because it's 21 times 10 plus 1 by the distributive property. So in that case, you get 231 as a denominator, which is answer choice B. And yes, I see a question in the chat that says it is 231. Yeah, that's right.
That guy's pretty fast. I guess let's wait a little bit, and if there's no questions, we can do some polls.
So yeah, that.
I think
So,
somebody
let's
had
do
asked
some-
if this is recorded. The session is being recorded. We will soon upload that to our North South YouTube channel as well. We encourage everyone to subscribe to the North South YouTube channel so that you can go through these and other useful sessions. Hari?
I think we can go on to the polls. Yeah.
Well, okay. If everybody could make a selection for the answer. So North South, yeah, you might have seen some of the webinars. We also host regional contests in April, and based on the performance at regionals, you could be invited to nationals in August. And then we also have coaching sessions in fall, and then some in spring, and a few in summer as well. So I hope, yeah, you can visit northsouth.org to get more information. And okay, so I think we can close this poll. Oops. Let me just share results. Okay, so it looks like 57% of them already are aware of North-South Bs and participate them. Okay, so let me just have the last question. Like I said, Math B will be on April 9th or April 30th, depending on which chapter you belong to. So if you have not already registered, we encourage you to register for the North-South Math B and look at other competitions that you may be interested. Science, history, geography, and there's a computer science B also for high schoolers, and a brain B for middle school and high school, and spelling vocabulary as well. Okay, so let me just close this poll as well. Share results. So 36% have already registered and 20% most likely to register. And if you have, if you need more information about the North-South Map B, you can visit northsouth.org and look up the information. We also have Meet the Pro sessions for different Bs. So Map B session has just completed last week, and you can see that also on the North-South YouTube channel. Thank you. Over to Anusha.
So guys, we will do 4 more questions today, and please join us for the session tomorrow where we will complete the rest of the problems. So yeah, after Anusha finishes her problems, if you guys could stay back, we can make sure that you guys know how to register for the second session. But enough of my talking, and Anusha, you can start.
All right, so I'm Anusha, and I'll be doing problems 9 through 16 today. So let's start with problem number 9. A cup of boiling water at 212 degrees Fahrenheit is placed to cool in a room whose temperature remains constant at 68 degrees Fahrenheit. Suppose the difference between the water temperature and the room temperature is halved every 5 minutes. What is the water temperature in degrees Fahrenheit after 15 minutes? So let's start by congregating all of the information because we're thrown at us, 6 different numbers, and it's a lot. So let's start by gathering up all the information we have and taking this step by step. So we have a cup of boiling water at 212 degrees Fahrenheit and a room temperature, which is constant at 68 degrees Fahrenheit. That's an important piece of information. So let's jot that down. So water initial temperature is 212 degrees Fahrenheit, and the room temperature is 68 degrees Fahrenheit. The difference between the water temperature and the room temperature is halved every 5 minutes. We need to know the water temperature after 15 minutes. So 15 minutes is a very short period of time, and we're given that the temperature difference between the water and the room is halved every 5 minutes. So let's look at this in intervals of 5 minutes. So after 5 minutes, after 10 minutes, and after 15 minutes. Those are the 3 temperature intervals we're going to look at. So the first thing we need to do is figure out the initial temperature difference between the water and the room. So the initial temperature difference we have is 212 minus 68, which is equal to 144 degrees. The problem tells us that after 5 minutes, this difference is going to be cut in half. So 144 divided by 2 is 72. Then after another 5 minutes, or after 10 minutes from the start, our temperature difference is going to be cut in half again. So we're going to do 72 divided by 2, which is equal to 36. After another 5 minutes or 15 minutes from the initial start time, the temperature difference is going to be cut in half once more. So that's 36 divided by 2, which is equal to 18. So after 15 minutes, the temperature difference between the room and the cup of water is 18 degrees. So that number is the temperature difference, but the question is asking us what the water temperature is. So if the temperature difference between the room and the water is 18 degrees, and the room temperature stays constant at 68 degrees, we can figure out that the temperature of the water is going to be 68 plus 18, which gives us an answer of 86, or option choice B. So that's a lot of information, so I'm going to let that sink in and wait for any questions.
So far, there are no questions. I said that we were going to do 4 more questions, but we're going to do questions until time's up. Sorry about that. But
yeah, that's good.
Someone's asking, is there any relevance of the concept of exponential decay in this problem?
So exponential decay, yes, for sure. So I mean, what we can do is we could set up an exponential decay equation with our initial temperature difference and the amount that it decays over time. I just thought that for the sake of this problem and for the level that most of the participants are at, probably middle school 6 to 8, you might have learned exponential decay, but when you're solving this problem during the AMC, most of this would be mental math. So it would be probably done much quicker. So if you're asking if there's a quicker way to do this, probably, but most of this would be mental math. So it would take a lot less time.
The second question was, could you explain the plus 18 one more time?
Yeah, of course. So we figured out that after 15 minutes, the temperature difference between the water and the room is 18 degrees. That's just the difference between the two objects. The water and the room have a difference of 18 degrees. So what's the actual temperature of the water? The problem gives us that the temperature of the room remains the same. It's never going to change. It's always 68 degrees. And the water is the one that's cooling down. So the temperature of the water is going to be 18 plus 68 because the difference between the air and the water is 18 degrees. So that's why we're adding 18 there.
I think we're good to keep going. So
great. All right, so let's move on to problem number 10. Right off the bat, it looks quite interesting as we have several graphs for our option choices. One sunny day, Ling decided to take a hike in the mountains. She left her house at 8 a.m., drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10 a.m. After hiking for 3 hours, Ling drove home at a constant speed of 60 miles per hour. Which of the following graphs best illustrates the distance between Ling's car and her house over the course of her trip? Again, here we have a lot of numbers. We have a speed, we have some times, we have, a duration, 3 hours, and then another speed. That's a lot of information to digest at once. So let's split this up. So we're going to split this up into journey to the hike, hiking while she's actively hiking, and journey home. Those are the 3 legs of the trip we're going to split this into. So we don't need to do a lot of really specific numeric calculations because all of our answer choices are graphs. So let's take a look at this logically. And let's try to fill in information from the problem. She left her house at 8 a.m., drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10 a.m. So on her way to the hike, she drove at 45 miles per hour for 2 hours. From this, we can determine that the distance between Ling's house and the hiking trail is 90 miles. Why? Because it's 45 miles per hour for 2 hours. 45 times 2 is 90. So she is covering 90 miles there and back. So looking at our graphs, let's see if we can eliminate any of the answer choices that don't make sense. We know that the y-axis, or the vertical axis going up and down, that's our y-axis, is distance. So we need to eliminate any of the graphs that don't have a distance of 90 miles. So our first graph, it looks like we're good. See, this is like reaching our 90-mile mark here. Looks like we're good, so that A is still in the running. B, however, only reaches a distance of a little over 30 miles for the journey to the hike. So that means we need to eliminate answer choice B. Answer choice C, same thing. We're not reaching a height of 90 miles, reaching a little over 30 again. So it's not answer choice C either. Answer choice D, this is too far. This is around 120 miles. So it's not answer choice D either. Answer choice E, it looks like we're still good because we have 90 miles right here. So now we're just determining whether the answer is A or E, which is a great strategy because we only have 2 options in the running. Let's take a look at her actual hiking journey. So she hikes for 3 hours. Let's look at our graphs and see if we can eliminate anything possibly. So in graph A, it looks like I'm seeing a hike of 3 hours there, so that's still good. And then for option choice E, again here I'm seeing a hike of 3 hours, so that's good. We need to move on to the final piece of information given to us in the problem. She drives home at a constant speed of 60 miles per hour. What can we do with this information? Well, the first thing I notice is that her speed on the way there and her speed home are 2 different speeds. She drives to the hiking site at a speed of 45 miles per hour, but she returns home at a speed of 60 miles per hour. That means that when we're looking at a graph, the rate of change of the journey has to be different on the way there and the way home. So as we see here, these two lines have identical slopes, which indicate that in this graph, the speed on the way there and the speed home are the same. That's not what the problem tells us. However, in option choice E, we can see that the speed on the way there and the speed home are 2 different speeds. Another way to possibly look at this is if that confused you. So our option choice is E because we eliminated A. If the whole speed thing confused you, we can look at this a little more numerically. So I'm going to erase this to create a little bit more space. On the way there, she drove at 45 miles per hour for 2 hours. So that means she covered 90 miles. On the way home, she drove 60 miles per hour. And remember, she still has to cover those 90 miles. That's not going to change. The distance between the site and her house is not going to change. So we have 90 miles per hour, or 60 miles per hour for 90 miles. So I'm actually going to fix that. So it's 60 miles per hour for 90 miles. That gives us a time of, so we have it takes her 1 hour to go 60 miles, to go 90 miles. We're going to do our dimensional analysis. It's going to take us around 1.5 hours. So on the way there, it takes us 2 hours, and on the way back, it takes us 1.5 hours. Looking at our graphs, graph A shows a time of, let's see, on the way there, it shows us a time of 2 hours, and on the way home, it shows us a time of 2 hours. That's not correct. But in option choice E, on the way there, it shows us a time of 2 hours, which is correct. And on the way home, it shows us a time of 1, and then this is half an hour right there. So that makes option choice E the correct answer. I know that was a lot, so I'm going to give it a minute for any questions.
So someone's concerned about how long this took to explain. So if you want to give some competition advice. That'd be cool.
Yeah, of course. So competition advice wise, I would go with the first way that I explained it. You quickly look at the information, you summarize it. Of course, I'm explaining it pretty slowly so that if you didn't understand this problem at all, you'd be able to get it step by step. But if you're in the competition mindset and you want to solve it quickly, I would say summarize your information the way I did with the 3 rows, you know, the trip there, during the trip, after the trip. Eliminate option choices as you can, as we were doing. We were doing it a little slowly, but during the competition, a lot of it will be mental. You'll be able to do it like this because a lot of this math is really simple. Like you don't have to write all this out because 45 times 2, you would know that it's a 90-mile journey. So eliminate option choices as you can, summarize the information, and, you know, use some critical thinking skills. You know, in the beginning, I was saying that your speed on the way there and your speed back are different, which means that the slopes of these 2 lines would have to be different. That you can get instantly without having to do calculations. So from a competition mindset, this problem shouldn't take more than like 2 minutes.
I think that's good, and let's keep going.
Perfect. All right, so I think we're gonna have to switch over to the second Jamboard. So let's do that. All right, problem number 11. Henry the donkey has a very long piece of pasta. He takes a number of bites of pasta, each time eating 3 inches of pasta from the middle of one piece. In the end, he has 10 pieces of pasta whose total length is 17 inches. How long, in inches, was the piece of pasta he started with? Very strange problem, very strange context, a donkey eating pasta. But that aside, let's analyze this from a math point of view. So we have a piece of pasta going to be represented by this line. Perhaps it is a spaghetti noodle. This is the pasta that he starts with. It's the very long piece of pasta. Each time the donkey takes a bite of pasta, he eats 3 inches from the middle of one piece. So let's visualize that. He starts with one piece. He takes a bite out of the middle right here. So after that bite, he'll end up with 2 pieces. This is a 3-inch bite. And the total of these 2 pieces should be the total of this piece minus 3. So let's make that algebraic. So let's say the length, the original length of the pasta was L. After he takes the 3-inch bite, the total amount of pasta he would have is L minus 3. Let's say he took another 3-inch bite. Remember, it doesn't matter which piece of pasta he takes the bite from. He can take the bite from either this piece or this piece, and it wouldn't matter. He just takes one bite that is worth another 3 inches. So then he'll end up with 3 pieces of pasta. He's taken 2 bites so far, remember. And this length would be L minus 3 from before, and then minus 3 again, because he takes another bite. So that's L minus 6. Let's see if we can notice a pattern forming. So I'm gonna make a little more room here. So he starts off with one piece of pasta. Then he takes a bite. He has 2 pieces, 1 bite. So this is L units long. And then after the bite, it's L minus 3 units long. Then when he takes another bite, he ends up with 3 pieces, 2 bites, and L minus 6 inches of pasta. So we can notice a pattern starting to form, and we can apply this to what the problem is asking. In the end, he has 10 pieces of pasta whose total length is 17 inches. So we can continue this pattern. When he has 10 pieces of pasta, he would have taken 9 bites, and he would have had L minus 27 units of pasta left. Because as we notice, this number right here that we're subtracting is the number of bites taken times 3. That's what we're subtracting from the total length. So the number of bites taken here is 9. 9 times 3 is 27. So we know that L minus 27, and we're given in the problem that he's left with 17 inches, is equal to 17. That's the equation that we can set up using what we've deduced so far. So adding 27 to both sides, we get L is equal to 44. That is option choice D. Gonna give it a minute for any questions.
Could you explain the part you did in red one more time?
Yeah, of course. So once we get to the 10 pieces and he's taken 9 bites, he has left over from the original L units of pasta, L minus 27 units, because each time he takes a bite, he's taking out 3 inches. So if he takes 9 bites, he's taking out a total of 27 inches. So that's L minus 27. That's how much pasta he has left when he's taken 9 bites. We're also given in the problem that the total length of all that, once he has the 10 pieces of pasta, the length of all that pasta is 17 inches. So that's why we're setting L minus 27 equal to 17, and then we're solving it using our simple algebra. So adding 27 on both sides, and then we get 44.
And then, do you see a simpler way to do this? I see a simpler way, but it's pretty much the same way. It's just we skip a little bit of the logic.
Yeah, exactly. I just had to explain the logic step by step because, again, if you didn't understand the problem at all, there's no way I could explain it super quickly. So that's why I always explain these problems step by step. A lot of this, again, would be done in your head. You probably wouldn't even need to write anything down here.
Right. So just like, guys, visualizing the break, right? Each bite is going to give you 1 extra piece, right? So 9 bites is going to give you 10 pieces. Well, 9 bites is 3 inches. So that's how you get it faster, right?
Exactly.
I think there's a lot of questions about the recording. So the recordings will be sent to you via email. Last year we have put the AMC 8 recording on YouTube, so you might find it there. But in general, if you want to watch this, you'll get it because you're registered. So I think with that, let's keep going.
All right, we're powering through these problems. We're already at number 12. The arrows on the 2 spinners shown below are spun. Let the number n equal 10 times the number on spinner A added to the number on spinner B. What is the probability that n is a perfect square number? So again, we have to take this step by step. If you have no idea what's going on, the best thing to do is identify each piece of given information and apply it to the context of the problem. So let's do that right now. So we have 2 spinners, spinner A and spinner B. The number n is equal to 10 times the number on spinner A added to the number on spinner B. So let's visualize that for a second. Let's say I spin the spinner and I spin spinner A first. Let's say I'm just coming up with a hypothetical situation so we can really wrap our head around this problem. So I'm spinning spinner A and I land on 5 as shown here. Then I spin spinner B and I land on 2 as shown here. Well, then the number n would be equal to 10 times the number on spinner A plus whatever number's on spinner B. So the number n would be 10 multiplied by 5 plus 2, which is equal to 52. That's a hypothetical situation. That means that n is always going to be a 2-digit number. The next part of the question asks, what is the probability that n is a perfect square number? A perfect square number is a number that can be represented by the product of 2 of the same numbers. For example, 2 times 2 equals 4. 4 is a perfect square number. 3 times 3 equals 9. 9 is another perfect square number, and so on. So now that we've cleared up all our necessary vocabulary, perfect square numbers. We know that n is 2-digit and it needs to be perfect square. Let's make a list of all of our 2-digit perfect square numbers. So we have 16, 25, 36, 49, 64, and 81. Just for the sake of time, I'm not going to explain how I got each of these numbers. These perfect square numbers are a concept that's taught in middle school, so you should be pretty familiar with that if you're writing the AMC. So all of these are 2-digit perfect square numbers. So where do we start? We have this pretty decently long list here. However, one thing to notice is that some of these numbers are impossible to achieve. How, you might ask? Spinner A only has 4 numbers on it. Since the result on spinner A would end up in the tens digit, the tens digit is the first digit right here as I'm underlining, that means that the tens digit of n has to be either 5, 6, 8, or 7. That eliminates quite a few answer choices. That eliminates 16, 25, 36, and 49. Because all of those have a tens digit of 1, 2, 3, and 4, which aren't even on spinner A, so we can't even get those numbers. The remaining 2 numbers are 64 and 81. 6 and 8 are luckily on spinner A, so we're good there. Let's look at spinner B to make sure that those numbers are still achievable. So we have 4, which is on spinner B, and 1, which is on spinner B, so we're good. So the only 2 perfect square 2-digit numbers that we can arrive at are 64 or 81. So if we need the probability that n is either 64 or 81, well, probability is, it goes like this. It's favorable outcomes over total possible outcomes. Again, here you should be pretty somewhat familiar with the concept of probability, but our favorable outcomes are what we want to happen. So we want either 64 or 81 to appear. So that's 2 favorable outcomes. And the total number of outcomes, or the total number of different 2-digit numbers that we can get, is 16, because there are 4 numbers on this spinner times 4 numbers on this spinner. So our probability is 2 over 16, and if we reduce this fraction, we get 1 over 8, which is option choice B. So take a second, and I'll answer any questions.
I guess in the meantime, you want to talk about like how it's kind of important to know your perfect squares?
Yeah, it's definitely important. In math competitions like AMC, a lot of it is logic-based and based on some pretty basic number theory. So in order to arrive at this more complex number theory, it's important to know things like probability, and knowing these perfect squares is really useful in this case, because otherwise you're gonna have to sit there and calculate each one. You're gonna have to go 4 times 4. Okay, that's 16. 5 times 5, that's 25. And that'll just take a little longer. In a competition of speed, it's helpful to know stuff like this.
So there's a lot of questions on how you arrived at like how it was a 2-digit number and how you knew and why you were looking at the tens place.
Sure. So I know it's a 2-digit number because, okay, so the question is, why is n a 2-digit number? Right? So the number n is 10 times whatever appears on spinner A plus spinner B. 10 times whatever number appears on spinner A plus spinner B. That will always be a 2-digit number, because let's say no matter what number you arrive here, it'll always be either 50 plus whatever appears on spinner B, or 60 plus spinner B, or 70 plus spinner B, or 80 plus whatever appears on spinner B. That's always a 2-digit number. So no matter what you spin on spinner A, n will always be 2 digits. There's no way it can be 1 digit, because you're multiplying the result of spinner A by 10. And then the second question was, why are we looking at the ones digit here when we were eliminating options? Was that the question?
Yeah. So like, yeah.
So spinner A is, so sorry, I just moved the question. Wow. Okay, so whatever appears on spinner A is going to be our tens digit, because when you're talking about a number, any number can be represented like this. So the number, this is unrelated to the problem, the number 26 can be represented 2 times 10 plus 6, because 2 is in the tens place and 6 is in the ones place. So we're looking at the tens place of each number because the number n is 10 times A plus B. So that's why the tens place will always be the number from spinner A. So it's either going to be, as we were looking at down here, 50 plus something, 60 plus something, 70 plus something, 80 plus something. The tens digit always has to be 5, 6, 7, or 8, no matter what you get on spinner B. I hope that makes sense.
And then really quickly, can you explain how you got 16 as your denominator?
Yeah, of course. So the total probability is favorable outcomes over total outcomes. The total possible number of 2-digit numbers that we can spin is 16, because there's 4 different tens digits that we can get and 4 different ones digits that we can get. So you have to multiply those to get 16.
I think we're good. Let's finish it. Let's keep going.
Perfect. All right, so this is question number 13. How many positive integers can fill the blank in the sentence below? One positive integer is blank more than twice another, and the sum of the two numbers is 28. So right off the bat, you might be thinking to yourself, wow, there's a lot of unknowns in this problem. How are we going to solve this? Because the elementary rule you always learn in algebra is 1 unknown, 1 equation, 2 unknowns, 2 equations. So we have this many unknowns. How can we form this many equations? Let's tackle this step by step. So the statement is one positive integer is blank more than twice another, and the sum of the two numbers is 28. Let's make this blank a variable. Let's say it's a. So we have one positive integer is a more than twice another, and the sum of the two numbers is 28. Let's say our first number is x. That means that our second number is a more than twice of x. So it'll be 2x plus a. That's just basic, comprehension. It's a skill that's really important to have in problem solving, especially math problem solving, is you need to understand what the question is asking. So having these two is basic comprehension as to what your problem is asking. So one integer is x and one integer is 2x plus a. We also know that the sum of the two numbers is 28. So x plus 2x plus a is equal to 28. Let's expand this and try to work with it a little bit. So we have 3x plus a is equal to 28. All right, so this is our primary equation. From the givens of this problem, we can't really form a different equation and try to solve for both variables. Additionally, the problem is asking how many different positive integers can a be? So what are the possibilities for a? That indicates that there's more than one answer for a. That means we can't set up a definite equation and solve for our variables using, system of equations. We can't do that here. So we need to figure out all the ways that we can replace a with an actual number and have this equation work out. Remember, it needs to be a positive integer, and our two numbers are positive integers as well. So we need to keep that in mind. So if we're solving for a would be equal to 28 minus 3x. So a needs to be a positive integer. That means that the value of 3x cannot exceed 28. If the value of 3x is any higher than 28, a will be a negative number. For example, if 3x is equal to 30, we'll get a is equal to 28 minus 30, which is equal to -2. That doesn't fulfill the requirements of this problem. That means that 3x needs to be less than 28. So 3x needs to be less than 28. That means x needs to be less than 9 for this equation to work with all the constraints given in the problem. If we notice, so x needs to be less than 9. That means that x can be any number from 1 to 9. That gives us an answer choice of D right there. Because so from our problem, our constraint is that a needs to be a positive integer. And then from here, we further made the constraint that a needs to be less than 28, because a is a positive integer. So that means that if x is less than 9, x can be any number from 1 to 9. And then when you do 28 minus 3 times x, you'll end up with 9 different values. So that gives us an answer choice of D. I know that was a little bit confusing, and there are a few different ways to approach this problem, but this is the way that I personally would have approached it, and I would have solved this problem.
Could you just explain that really last bit and why it's x can't be 10 but rather 9, and how you got 9?
Yeah, sure. I know that part is a little bit confusing in this problem because it's a little difficult to wrap your head around, but I'll go through it once more. So from this equation, we've isolated a. We have a is equal to 28 minus 3x. Reminder that a needs to be a positive integer because that's how many positive integers can fill in the blank, and we've set a as our blank here. So a needs to be positive, and it needs to be an integer, which means it can't be 0. Or it can be 0, but a needs to be positive, that's all. So to keep a positive, we need this value right here. So we have 28 minus something. This something is 3x. 3x just needs to be less than or equal to 28. So actually right here, this should be an equal to sign because x can be 9 still. So if we have that, so x can pretty much be anything from 1 to 9, because when we multiply that by 3, it needs to be positive still. If this is anything more than 9, then this statement won't work out. Let's say x is 10, then we'll have 28 minus 30, which is equal to -2. But that doesn't fulfill the requirement in this problem. So that's why we need x to be from 1 to 9. And if it's from 1 to 9, then the conditions will be fulfilled in this problem, and then when we're subtracting from 28, a will still be a positive integer.
I think that's good. Let's keep going.
All right, problem number 14. In how many ways can the letters in beekeeper be rearranged so that 2 or more E's don't appear together? Okay, so now we're dealing with some letters and some words, which is kind of confusing in math, but let's take a look at it anyways. So 2 or more E's can't appear next to each other. Let's see, we count 1, 2, 3, 4, 5 E's in this word. And there are 4 other letters. There's B, K, P, and R. So we have B, K, P, and R, and 5 other E's. So that means the arrangement needs to look something like this. It needs to be E, some other letter, E, another letter, E, another letter, E, another letter, and E. So that's what our setup is going to look like. This is the only way that we can set this word up without the E's touching. There needs to be one letter separating each E. Letters we have to work with are B, K, P, and R. So in how many ways can we fill in these blanks in total, right? How many ways can we put B, K, P, and R in these blanks? How many different combinations are there? So there's two ways to solve this. The first way is using factorials, which I'll explain in a second. And the second way is what I'm going to do right now. If you're not familiar with factorials, pay attention right now. So without using factorials, the way I would approach this is by taking a test case and then multiplying it by 4. And I'll explain what I mean in a second. So let's say B is our first letter here. We just need to put K, P, and R in these 3 blanks and keep shuffling it up. Once we figure out how many combinations exist with B in this position right here, we can just multiply that by 4 for each of these letters taking the second position. So if B is in the first position, we can have K, P, and R here. And we can have K, R, P. And we can have P, R, K. And P, K, R. That looks like an R, sorry about that. P, K, R. Then we can have R, K, P. And R, P, K. So those are all the combinations that can exist with B taking the second spot right here. That is 1, 2, 3, 4, 5, 6 outcomes. So we have 6 different combinations that exist when B is in this second position right here. So if we do that for each of these letters, that's 6 times 4, which is equal to 24 outcomes. Now, if you're familiar with the concept of a factorial, you could just take one look at this problem and do 4 factorial, which is equal to 4 times 3 times 2 times 1, which will give you the exact same answer of 24. I just wanted to explain it both ways for people who weren't familiar with factorials.
Yeah, I guess the factorial, for those that don't understand that, it's just the intuitive way of saying there's 4 ways to choose the first space, 3 ways to choose the second, 2 ways, and yada yada.
Yeah.
So far there's really no questions. You can use the NPR equation. That's what we're talking about.
Mm-hmm.
That was pretty clean.
Thank
You know,
you.
the E's are starting to social distance. It's kind of
Yes,
fun.
agreed. 6 feet.
I think we're good. We explained that pretty well. So nice
All
job.
right. So let's quickly move on to problem number 15. Laszlo went online to shop for black pepper and found 30 different black pepper options varying in weight and price, as shown in the scatter plot below. In ounces, what is the weight of the pepper that offers the lowest price per ounce? My first thought is, why would you be online shopping for black pepper? My second thought is, what is a scatter plot? So let's dissect that right now. A scatter plot is when you are plotting different points based on 2 different variables. So we have weight in ounces on the x-axis and price in dollars on the y-axis. So for example, if we isolate this point right here, we have a weight of 1 ounce that's going for a little over $1. That's one of the data points that he found when he was online shopping for black pepper. So that's just a quick summary on the scatter plot thing. So the question is asking, in ounces, what is the weight of the pepper that offers the lowest price per ounce? So there are so many different data points here. How do we approach this? Well, you might notice that price per ounce, that is price per ounce, price divided by weight. That looks familiar. That looks like the slope of a line on the scatter plot. So we know that if you buy 0 ounces of black pepper, you are not paying any money at all. So 1 point on this graph for sure is 0, 0. If you connect 0, 0 with any other point on the scatter plot, the slope between those 2 points is going to be your price per ounce. So essentially, we just have to find the line with the smallest slope. As a quick refresher, lines with larger slopes are going to be more vertical, more close, lines that look like this, closer to the y-axis. And lines with smaller slopes are going to be closer to the horizontal axis. They're going to be more flat. So we need to find the point that makes a line with this point right here with the flattest slope. So kind of eyeballing it right here, we have this one looks pretty flat. This one right here. There's a few others, this one right here. Overall, though, this point is really sticking out to me as a point that's making the flattest line. I'm going to outline that in a different color. That line looks like it's the closest to the x-axis. So that means that this data point right here, which is 3 ounces for a little over $2, is going to be our cheapest pepper option. So if you're a pepper connoisseur, 3 ounces of black pepper is going to be your cheapest option. So that's option choice C. So pretty intuitive question overall, but can wait for any questions.
I guess the one question was, could you repeat how you found the lowest one?
Yeah, so finding the lowest one is a little bit of a trial and error type thing. So what I did was, that 0, 0 has to be a point on the graph. If you buy 0 ounces, you're not going to be paying any money. So 0, 0 is a point on the scatter plot. So what I just did is the method I use is I just kind of try to start to connect a few lines here, and some that might look. You're definitely not going to want to connect any up here because those are going to be pretty high slopes. Connecting stuff up here, that's not even worth it. But I'm looking at some points down here, and overall, this is looking to be the lowest slope. It's a little bit of an estimation type thing. So that's why I chose that as the data point for the correct answer.
Could you finally just explain why it's not the one at 5 ounces, like the lower one at 5 ounces?
Yeah, sure. So so we're looking at this data point right here. If I make a line connecting that, we're looking at a slope that's a little bit higher. Obviously, my line drawing skills are not perfect, but it's a choice of estimation. If you wanted to be really precise with that, if you think that, oh, I can't really estimate that, you can look at it from a slope point of view. So this point and this point, we have a slope of so change in y. So let's estimate that to be around. It's a lot of estimation because you're not given exact data points. We can estimate that to be like 2.5 divided by 3, as opposed to we have like 4.5. So comparing that with 4.5 divided by 5. So overall, it's a little bit of estimation. You're kind of looking at the graph and trying to determine it, but you can do it from a numeric point of view if you wanted to.
I think we're good for today. Vinay uncle, can you go over that registration thing?
Yeah, so the timing for tomorrow's session is the same as today. So 7:30 p.m. Eastern to 9 p.m. Eastern. And the registration link for tomorrow's session will send you an email today. So please use that to register for tomorrow's session. And yeah, and also I think we earlier shared the link for registering for the Math P as well, right? So yeah, please visit northsouth.org, and as a parent, if you your parent can log in and register you for the contest. And like I said, Math P is on April 9th and April 30th. So please look for your email tonight or tomorrow morning and register for the second session as well. So look forward to seeing you tomorrow as well. Thank you all for joining, and thank you, Hari, Agastya, Anusha, Ms. Sarojini, and Dr. Gauri for joining us today.
Thank you all. Those of you that wanted to solve these problems out before, you can find the AMC 8 problems online. Just look up AMC 8 2022. I'm pretty sure there's this company called Ivy League Institute that has the problems and the answers, and you guys can all come tomorrow for the solutions. So I think with that, good night, and I think we can stop the recording.
Yep. Thank you, guys. Good night, everyone.